Hey folks, how's it going? This is Mr. Murray coming to you with a video on the Hitting the Slopes packet. I hope that you find this video to be informational, and in this video I'm going to go through the actual problems and the topics one by one, talk to you about what you need to know, and hopefully this will help you be ready for the unit test, okay? So here's what you need to know. First, you need to be able to draw the graph for a piecewise function. You need to write the formula for a piecewise function given the graph. I have videos on both of those things. I encourage you to check those out. You need to model real-life scenarios with piecewise. This I've got a video on, graphing absolute value. I encourage you to look at this information to help you. To solve absolute value equations, remembering that when the bars are alone, if it's equal to a positive number, 2 solutions. Negative number, no solutions. 0, 1 solution. To solve absolute value inequalities and graph the solutions. Once the bars are alone, if it points away from the absolute value and towards a positive, and inequality, right? Away from bars towards a positive. If it points towards the absolute value and away from a positive, it's an OR inequality. Here's an example of an OR inequality. Towards the bars, away from a positive. If it points away from the absolute value towards a negative, no solutions. Away from it towards a negative. Remember, only when the bars are alone. And if it points towards the absolute value and away from a negative number, solution is all real numbers. Okay? Don't forget, when you multiply or divide by a negative number, you flip the direction of the inequality. The only thing that's kind of funky is when it's greater than or equal to 0. If it's greater than or equal to 0, again, that's all real numbers because all absolute values are greater than or equal to 0. If it's less than or equal to 0, technically, there's only one solution. So that's something that might be interesting to look at. And again, I encourage you to check out my video on this. Okay, finally, and I know this is a long video, but I encourage you to check out my video, analyze functions for domain and range, x and y intercepts, increasing, decreasing constant, positive and negative intervals, absolute and local max and min, and behavior, acts of symmetry, okay? And finally, to solve word problems about absolute value functions, this is my newest video. I encourage you to look at that as well. So I need you to work. I need you to help me help you. Coming in for extra help, watching my videos on these topics. And I think if you can do that, you're going to find yourself successful on this test. All right, so I thought I would take a second and go over the slopes that we're going to hit. The slopes are graphing piecewise, writing piecewise, graphing abs-val, solving abs-val equations, solving abs-val inequalities, analyzing word problems. Okay? So I'm going to go ahead and dive right in. Okay, piecewise graphing. This year, remember, this is the 2019-2020 handouts. In subsequent years, these might not be the same. This was 2-1 to 2-2. We hit the term ground running, and we went right into this. Explain how to graph a piecewise function from its formula. So remember, graphing. First, graph everything. And this is for each piece. Okay. Second, erase based on the inequality. Okay, so you erase where false, you erase. Okay? That's the basic steps. It's really helpful to be able to do this, and I'll show you with the eraser how to do this. Forgive me though, I just want to make sure my pencil is nice and sharp. Okay, so let's see how this works. First, x plus 2 is for x is less than or equal to 3, negative 3, and x, where x is more than negative 3. So let's take a look. So first, for each piece, we graph the whole entire thing. Intercept of 2, slope of 1. Graph the whole thing. Now, wherever it's false, I'm going to erase. So I'm going to erase wherever x is not less than negative 3. So here x is less than negative 3. Where is x not? Here it is. So I erase. Now, here's the step I didn't miss. Don't forget, you need to leave a dot on the end. So see, I get all the way down. And remember, it's not y. You don't stop at the negative 3 on the y. You stop at negative 3 on the x. What do I do? At that point, I leave a dot. Remember the Sophia H rule. More ink to do the or equal. More ink to fill in the dots. I hope Sophia H appreciates my continuing shout outs to her on this. Okay, now I'm going to do the next piece. The next piece is y equals x. So again, I graph the whole thing. And then I erase wherever x is not less than negative 3. I do an what kind of dot? An open dot. And I remember the HB rule, which is to put an arrow on the end because it goes on forever. And now I do my vertical line test. So I'm going to run a vertical line over. And with the exception of remembering that a closed dot and an open dot, you can't have two closed dots, I'm going to do my vertical line test. So the graph should only touch this vertical line at one point. See, this shows that it does. If you ever have a piece going back, you run your pencil, it touches at more than one point, that means there's an input with two outputs. It's not a function. This is a function. It has to pass the test. Okay, now I'm going on to my second one. F of x is 1/2 x minus 1 when x is less than or equal to 0. Negative 2x minus 1 when x is between 0 and 2. And negative 5 when x is more than or equal to 2. So this is a line or array, a line segment, array. Okay? When there's two endpoints, right? Think about it like this. Array has one endpoint. This has one endpoint, 0. A line segment has two endpoints. An array, one endpoint. So let's take a look. 1/2 x minus 1. So again, I graph the whole thing. Slope of 1/2, intercept of negative 1. So up 1 over 2, up 1 over 2, up 1 over 2, down 1 left 2, down 1 left 2, down 1 left 2. I'm stopping it when x is equal to 0. And I can already see that dot on my paper. Sorry for any shaking there. I just get very excited, so my camera sometimes shakes along with me. Okay, negative 2x minus 1. And I'm going to start when x is equal to 0. Because if you think about it, I can't have anything to the left. That's going to fail the vertical line test. So I start here. I start with an open dot, but this dot fills it in, so I'm fine. I go down 2 over 1. I go down 2 over 1. And now I erase everywhere where x is less than 0, which it's not anywhere, and more than 2, which it is right here. I go to the end. What kind of dot? Open. Make sure it's nice and clear that it's open. If you move into the open dot a little bit, that's okay, as long as you leave me a nice open circle so I can see that you meant to put an open dot in the end. I'm not going to get picky with you. Last step, negative 5. So watch what's going to happen. Well, look, I'm negative 5 here, so that negative 5 is going to fill in the dot, and it's negative 5, so it's a perfectly horizontal line, okay? So there's two skills involved. 1, you need to be able to graph lines. Important. 2, you need to be able to know where it starts and where it ends. Remember, we also have this thing called the May method, where you can do your vertical lines at those cutoff points so you know where it starts and it ends. Okay? And on that topic, I'll move to the last one, and I'll do the May method on the last one. Remember, this is the May method. The May method says you start by putting your vertical lines on the cutoff points. One cutoff point is negative 1. Another cutoff point is positive 2, and I just know that because of the inequalities. The next cutoff point is positive 4. and the last cut, and then I'm done. So here I go. First rule, negative x minus 3. Down 1 over 1, intercept of negative 3. So here's what it would be at. And I know that, I know people are going to be like, but Mr. Moret, you don't go past there. I would say this is why I advocate for doing the whole line. Because if you need to put the intercept in there to help you graph it, that's perfectly fine. Okay? But just remember that the intercept isn't actually in there because the intercept doesn't count. Because it's more than, the x is more than negative 1. And I leave an open dot at that point. Here's what I'll say. On a quiz or a test, if you want to do the May method and put the vertical lines in there, if it makes your graph correct, that's fine. I'm not going to grade you down if you put the vertical lines in there, if it helps make your graph correct, okay? You got my word on that. Now I'm going to do x squared. This is a parabola. So it's going to go from negative 1 to positive 2. So I know so now let's just plug in the endpoints here. So negative 1 squared is 1, close dot. 0 squared is 0. 1 squared is 1 times 1. 2 squared is 2 times 2. And I'm not going to go beyond that because it says I'm done there. The one thing I will change is remember to put a dot on the end. So that's another strategy for graphing piecewise. Plug in the beginning point, plot it, plug in the end point, plot it, connect between the two. It's more difficult with a parabola because it doesn't follow like a straight line like a regular line does. Okay, now negative x plus 6 from 2 to 4. Where would it start? Well, if I plug in 2, I get negative 2 plus 6 is 4. Fills it in. Now I'm going down 1 over 1, down 1 over 1 because that's the rule. And I do my closed dot because it's or equal. Last step, 1/2 x plus 2. So let's do this. If I plug in 4, a half of 4 is 2, plus 2 is 4. Now I'm going to go up 1 over 2, and that's as far as I can really go. And I do array. So remember, 1 endpoint means array. 2 endpoints, if it's a parabola, it's different, but it essentially means a segment. So this is a parabola segment, line segment, ray. Okay? So folks, I'm going to tell you this. On the test, at this point, I am not going to ask you to graph a parabola as far as I know because we're not at the point, and if I do, it's not going to be harder than x squared. We're not ready to graph parabolas. That's not for a couple more months maybe. So you do need to know, 1, how do I interpret the inequalities? Important. 2, you have to be able to graph lines. You have to, because these are in slope intercept. That was taught prior to this year. It was recapped briefly this year. I need you to know how to do that, okay? And if this is something tough for you, I recommend coming in for the extra help, okay? So if you need to, go back, take a look through what we did here, and then in a second, I'll move on to the next problem set. All right, here we go. So the next problem set is writing piecewise functions. So how do I write a piecewise function? Okay, so for each part, 1, write the rule for the whole piece. Meaning, like if it went on forever, what would the equation be? 2, okay? Write the corresponding inequality. Remember, okay, you're using the x values. Now, there's no guarantee that the f of x equals squiggly is going to be there. I did this to support you, to offer what I would call a scaffold. But on the test, there's no guarantee it's there. Okay, just want to let you know that. All right. Again, remember, open dot, one of these. If you see an open dot, close dot, means one of these. Don't forget about that. Okay, so here's my first piece. Got a flat line. I got a diagonal. What's this flat line? It's a horizontal, so it's a y equals 1. I know that because if it went on forever, it would have a slope of 1. I'm going to use the May method to see that it's -2, and if I zoom in, it looks like that was an open dot to me. So I'm going to say, and this is a closed, so let's assume that's true. And if it's not, it would just flip that around. X is less than or equal to -2, right? Because it goes up to -2. So see, if my turnover point is -2, that's got to be reflected there. Let's take a look at this next piece. Okay, it's got a slope of up 1 over 1, so that's 1x. If you write 1x, that's fine. I'm not gonna mark you down for that. It's the same thing as x. You could just write x or 1x. It's fine. Intercept of 0. You could write +0. I'll mark it 100% correct. You don't need to, because to add 0 is to leave it the same. So I'm gonna leave it as just 1x. When x is greater than -2, because x is -2 onwards, okay? So the biggest things I'm looking for, writing the pieces, these little details like the 1x, I'm not focused on that. And knowing how to interpret open dot versus closed dot, okay? So if you need a moment, go back ahead, reread that, and then in a moment, I'll move on to the next one. All right, now to the the black diamond. Okay, so I've got 3 pieces here. I'm going to do the May method. So it means I've got a cutoff. Now, these are actually both closed circles. So here's what I'll tell you. On the test, because we know sometimes one piecewise picks up where another piecewise leaves off, and the endpoints are perfect. If the endpoints are the same, you may do whatever you want for the or equals and the not or equals. But as I'm going to show you, if this is an or equal, the next point has to start with not an or equal, because you can only plug into one rule. Let me show you. So this first piece, up 1 over 1, that's a slope of 1. And if I was to keep going, notice how it would hit the y-intercept at 2. Okay, I like to do all the rules first. Here, flat line, no slope, as an intercept of 1. Last piece, it looks like a curve. I'm going to interpret this as a line. It goes up 1 over 3. So that's a slope, or rather, yes, up 3 over 1. Now, let's trace downwards. If I keep going along that line, I end up at -2. Okay, now here's where I'm going to let you have, so these there's no flexibility. It's clear, the rules. Here's where it's not clear. So let's say I say this is x is less than or equal to -1, because it starts at down, 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 goes all the way until x is -1. If it doesn't matter if you do less than or equals, because it's not clear based on how this is set up. However, on the next piece, I have to do something like this. So see, if this is a less than or equal to, this cannot be an or equal to, because then when I plug in, it's like I'd be plugging into 2 rules, and you can't have 1 and 1 both come out. Even though they're the same, I know it's technicality. If you put an or equal to in this situation, you leave this not or equal to, okay? Because you only plug into 1 rule. So notice how I chose to make that just a less than, even though it's not clear. So in this one, I'm going to do x is greater than or equal to 1. If that's not an or equal to, this is an or equal to. Sorry, a little hiccup there. All right. So remember, you're writing each rule one at a time. You're writing the inequalities corresponding one at a time. If you wrote like this, if you wrote 1 is less than or equal to x, these are equivalent, that's all right. Look, I'm not looking to pick on you in terms of where are they putting the 1, where they put, that doesn't matter to me. As long as the inequality is equivalent, I'm 100% fine with it. I care more that you can tell me what are the rules, where does it stop, and where does it end. Here, it matters. The x has to go between a -1 and a 1. But here, for example, if you did x1 is more than or equal to, -1 is more than or equal to x on the top, these are equivalent. So that's okay. I'm not looking to get picky there, okay? So again, go ahead and make sure you understood that, and then in a moment, I'll move on. All right, on to the next one. This one's tough because this one's made up of 3 segments. That's the only reason this one's a tough one. Note carefully, open dot, open dot, open dot. Okay? So let's start with the rules. This one, slope of 1, intercept of 0, x. Notice, -3, -3, -2, -2, -1, -1. Y is equal to x. And this is May method, quick little May method. X, so it starts at, now there's no arrow, so you have to have an endpoint. -3 is less than or equal to x, which is less than or equal to 0 because there's dots on the ends. Okay, second piece, 2, flat line, and that is x is greater than 0 and less than 1. Notice, or equal, not or equal. You can't have it both ways. This can't both be or equal. Because look, if I plug in if these were both or equals, I plug in 0, where do I plug into? Do I plug into 0 or do I plug into 2? That would be one input with 2 different outputs. We can't have that. Last piece, up 1 over 3. Here's where it's going to get tough. I might need to do a little bit of math here. So I know, if I come down here, that 1/3 x plus b has to be equal to y. And I know that if I plug in 1, what has to come out? 1. Okay, so I have 1/3 plus b is equal to 1, right? So that means b has to be equal to 2/3. So I've got 1/3 x plus 2/3. Let's see if it works with 4. If I plug in 4, I get 4/3. 4/3 plus 2/3 is 6/3. 6/3 is equal to 2. Okay, so that's a place where, you know, you might have a little bit of work that you've got to personally do there. And I've got 1 is less than or equal to x is just less than, because of the open dot, 4. Okay, so again, writing piecewise, what are we doing? 1, for each piece, we're writing its rule. Mostly going to be, I'd say 99% of the time, it's going to be a line. So you got to know the slope and the intercepts. Do not use point slope form here. It's just not going to work, right? Because y minus y1, or I guess y minus k, equals m, x minus h. You got the k there. Don't use point slope. Don't use standard. You don't have to. Don't be a hero. Keep it in slope intercept form. Okay, so you're writing each of the rules followed by each of the inequalities. Okay, so again, if you need to, go back and take a look. Remember, in the 2019-2020 handouts, it was 2-1 to 2-2 for your notes. Okay, and then in a second, I'll move on to the last problem. Or rather, the next set. All right. Boom. Graphing absolute value functions, okay? Remember, 2-3 in the 2019-2020 handouts, okay? What important information do you need to graph an absolute value function? You need 2 things. 1, you need the vertex, the HK. 2, you need the slope after the vertex, which is the A. Remember, after the vertex, it's A. Before the vertex, it's the opposite of A. Okay, so if it's 1 after the vertex, it's -1 before the vertex. Remember the shape. It's always making a V. When A is more than 0, it's a happy V. When A is less than 0, it's a sad V. Okay, let's take a look. Here's how I do it. And again, hopefully I'll put a little title card up here. I recommend you take a look at my video on this, because that's going to be really helpful here. Okay, so let's look at x is absolute value f of x is equal to the absolute value of x minus 3. First thing I do, I find my vertex. So I ask myself, what will make the bars equal to 0 Remember, in the end, you make a table, okay? But if you choose some smart numbers to plug in, it makes it easier. So 3, 0. Because when I plug in 3, this is 0, everything gone. How about 4? So you try to make the numbers in here small, okay? 4 minus 3 is 1. Absolute value of 1 is 1. I'm not adding anything there. 5. 5 minus 3 is 2. Absolute value is 2. Nothing to add on. 6. Okay, absolute value of 6. So we got 6 minus 3 is 3. Absolute value of 3 is 3. Nothing to add on. And just for giggles, I'll put in 7. 7 minus 3 is 4. Absolute value of 4 is 4. Nothing to add on. Now I'm on the end. So now let's go to continued. Next thing we add is 2. 2 minus 3, negative 1. Absolute value, positive 1. Note, if you didn't know how to do the vertex, note that you now have that repeating, meaning that this is your vertex and that's your axis of symmetry. So 1 should be 2. Let's see if that's the case. 1 minus 3 is negative 2. Absolute value is 2. So in the end, with an absolute value function, notice how I did not use the slope after the vertex rule. In the end, this is true. And listen, guys, I care about you. So I don't want to teach you tricks. Tricks are for dogs. I want to teach you tricks or strategies that will always work. And for every function we do this year, linear, absolute value, exponential, quadratic, next year, square root, cube root, polynomial, right? Cubic, for example, quartic. Even if we went to quintic, biggest power 5, making a table always 100% works. Making the thing equal to 0 helps you, but you can always make a table. Always, always, always works 100% of the time. If you can do that, we're good. Everything's gravy. If you can remember to do the y equals on your calculator, okay, plug this in. So you got y1. Remember, math, number, abs. Okay, it's in your calculator. So y1 equals bar. And then you do second plus graph. The calculator will make a table for you. So if you have that accessible, I'd recommend you think about practicing how to do that. That's okay. Guys, if I say you can do a calculator, you're good. You can do it. If you have access to it, you can absolutely have the calculator make a table for you. That's a completely valid strategy, okay? How about this next one? So here, notice that I'm going to do a table again, make a table. So look, what's the easiest number? What do? Cancel out the bars. Make the bars equal to 0. That's 5. Why do I say that? Because look, 6 and 4. When you plug in 6, you get 1. When you plug in 4, you get negative 1. Their absolute values are the same, therefore the corresponding outputs will be the same. If I plug in 7 or 3, I get 2 or negative 2. The absolute values in each of those cases, right? Absolute value of 2 is 2. Absolute value of negative 2 is 2. So the outputs are the same either way. The only number that has a unique output with regard to absolute value is 0, right? Because the absolute value of 0 is 0. The absolute value of 1 and negative 1 are the same. The absolute value of 2 and negative 2 are the same. The absolute value of 3 and negative 3 are the same. The absolute value of 4 and negative 4 are the same, and so on. That's why you make it 0, because 0 is the only number that has a unique absolute value, right? Only 0 gives you 0, right? 1 as an absolute value, well, negative 1 and 1 both have an absolute value of 1. Negative 2 and 2 both have an absolute value of 2. But only 0 has an absolute value of 0, and that's why making the bar 0 gives you the one unique output. And remember, the vertex is a point, is an x, and it's the only x with that given output, right? Only 3 gave me 0, right? So therefore, only 5 will give me negative 2. So that's a sign that 5, negative 2 is the vertex, okay? So now let's do 6. So I know that 6 and 4 will have the same output. So I plug in 6, 6 minus 5, absolute value is 1, minus 2 is negative 1. And remember, because of the symmetry, this beautiful symmetry, you get the same thing. Remember, why am I telling you this? Because when we get to quadratics, the A value in front, almost exactly the same. The 5 and the 2. If I put parentheses and a square, the vertex is exactly the same. Exactly 100% the same. That's why I'm trying to teach you these strategies now, because I promise you, if you can think about the idea of making it 0, it's going to help you with quadratics, square root, cube root, almost every single function that follows this HK form. It will always be an important point 100% of the time. I promise you. So please help me help you on that. 7. I plug in 7. 7 minus 5 is 2. Absolute value is 2. 2 minus 2 is 0. Okay? With absolute value, we're good. I would say get at least 5 points. And then please help me help you. Keep your graph going all the way to the edges. Okay? You get the complete picture. On a test or quiz, if it was paper, you'd have a ruler to help you with that. Okay? All right, last one. Build my table. Okay, notice, what's the unique output? Remember, whatever makes this 0 is going to be the thing with the only unique output, right? So for example, negative 4, okay, that will make it a negative 1 in here. When I take the absolute value, I get 1, right? Now, negative 2, when I do negative 2 plus 3, I get 1. So this, when I add 3, I get 1. This, when I add 3, or rather, I get negative 1. This, when I add 3, I get 1. Well, negative 1 and 1 will have the same absolute value. Therefore, they'll have the same output. If I do negative 5 and negative 1, well, negative 5 gives me negative 2. Negative 1 gives me positive 2. But negative 2 and positive 2 have the same absolute value. Therefore, they'll have the same output. So remember, the only number where you won't have that is what makes this 0. Because 0 is the only number with an absolute value of 0. That's really, really important. So I'm going to do negative 5, negative 4, negative 2, negative 1. And then what makes this 0 is negative 3. Again, please help me help you by thinking about those commonalities. So look, I plug in negative 3. This becomes 0. Negative 2 times 0 is 0. 0 plus 4 is 4. So I've got negative 3, 4. Now notice this is negative, so I should have a downward pointer. Okay, negative 4. Negative 4 plus 3 is negative 1. Absolute value is 1. 1 times negative 2 is negative 2. Negative 2 plus 4 is 2. And I know 2 is going to give me the same thing, because negative 2, because negative 2 plus 3 is 1. And since 1 has the same absolute value as negative 1, doing the rest of it's not going to change. And you can verify that for yourself by plugging in. Negative 5. Negative 5 plus 3 is negative 2, just like negative 1 plus 3 is positive 2. So the absolute value of negative 2 is 2. 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. And you can confirm that you get the exact same thing. And I'm just filling in these points because I know there's the pattern. And the more points I put on, the more accurate it's going to be. Here's the deal, though. I will not give you, if I ask you to manually generate a graph, I will not give you full credit if you put in any less than 5 points, including the vertex. You must have a vertex and 4 other points for full credit. I will not give you full credit if you have anything less than that, okay? And I'm trying to do that, I promise, to help you in the future. Okay, so that was this part. Again, I encourage you to take a second, rewind if need be. All right, and then when you're ready, go ahead and move on. Okay, so absolute value equations, the next topic here. and remember, this is 2-3 from the 2019-2020 note set. When solving absolute value equations, what are some important things to remember? The most important thing is you want to get to bars alone. Get the bars alone. And then remember, bars equals a positive, 2 solutions. Bars equals 0, 1 solution. Bars equal a negative, no solutions, okay? Because the only numbers that come out of absolute value, remember, absolute value is distance. Distance has to be positive or 0. Distance can never be negative, okay? So, and again, I'm trying to tell you this because in the future, we're going to see other situations, hint, hint, parabolas or quadratic equations with the same exact idea. All right, so let's go ahead. Let's take a look here. Are we in bars alone? No. What do we have to do? Subtract 2. So x minus 3 equals 5. Now we take the bars off. Taking the bars off means think. What numbers have an absolute value of 5? Either 5, so if this is equal to 5, we get 5, or negative 5. Okay, so it's now add 3, x equals 8, add 3, x equals negative 2. Please check your work. So let's come back. 8 minus 3 is 5. Absolute value of 5 is 5. 5 plus 2 is 7. Perfect. Negative 2 minus 3 is negative 5. Absolute value of negative 5 is 5. 5 plus 2 is 7. You check your work. You get it to work. You walk out of the test knowing your answer is correct. I'm not telling you it to annoy you, to give you another thing to do. But I'm telling you, in college, I always check my work. And you know why? Because each test I took in college was like 25% of my final grade. I want to walk out knowing that my answer was 100% correct. That's the only way to know, okay? Is to check your work. All right, how about this one? Are the bars alone? Nope, let's get them alone. So I add 13, 12, and I get x plus 6 in bars is 23. All right, this is positive, 2 solutions, so we can split. So either x plus 6 is 23 or x plus 6 is negative 23. All right, so let's go ahead and subtract 6 on both sides. So I get x is 17 or x is negative 29. Let's do a check. 17 plus 6, that's 23. Absolute value of 23 is 23. 23 minus 12 is 11. All right, negative 29 plus 6 is negative 23. Absolute value of negative 23 is 23. 23 minus 12 is 11. That's correct, okay? How about we move to the next one? Let's look at the next one. So here we go. Are the bars alone? The bars are not alone. So let's go ahead and take a look. So first step, minus 5. Do not divide by 2. When you're doing bars alone, pretend like this is your equation. Pretend like, forget about the bars. Let's say it was a letter. How would you get y alone? You would never divide 2 first, negative 2 first. You'd always, so you're not, if you wouldn't divide it here, don't do it here, okay? Start with the subtraction. So I subtract 5 on both sides, and this is what I get. Now I divide by 2. And I'm up to 7. Now it's positive. There's 2 solutions. I take the bars off. So either x minus 9 is 7, or it's negative 7. I add 9 on both sides. I get x is 16. I add 9 on both sides. I get x is 2. Notice how 16 and 2 are both 7 away from positive 9. Okay, just like with the word problems, right? This is 7 above, this is 7 below. Okay, again, check our answers. 16 minus 9, that is 7. Okay, absolute value of 7 is 7. 7 times negative 2 is negative 14. Negative 14 plus 5 is negative 9. All right, 2. 2 minus 9, negative 7. Absolute value 7. 7 times 2, negative 14. Negative 14 plus 5, negative 9. Correct. Here's the mistake people make. They go, no solution, there's a negative. But in the beginning, bars are not alone. You cannot say no solution until the bars are alone and it's equal to a negative. That is true of absolute value equations with regard to the bars alone and inequalities, okay? This one, let's take a look. So again, first step is going to be to add the 12, just like I did above with the 12 this time, not 13. Now I multiply or divide by negative 1. In this case, it doesn't matter. Okay, now the bars are alone. No solution, it's equal to a negative. Let me show you what happens if you try to split it up. So let's say I try to split it up. Okay, x plus 12 equals positive 23. Let's say I try to split it up. So I do my math. All right, I get negative 35. I get, let's see, negative 11. Rather, positive 11. Let's see if my answers are right. Okay, so I plug in negative 35. I get negative 23 when I add 12. Absolute value of negative 23 is 23. This makes it a negative 23. I subtract 12. I'm at negative 35. That's not equal to 11. 11. 11 plus 12 is 23. Negative 23, because the absolute value of 23 is 23. This makes it a negative 23 minus 12. No. Okay? So notice how if you accidentally take off the bars and plug it in, that's why you plug it in. Because then, if you actually do that, you're going to see that neither of your values work, and that's because there was no solution on this one, okay? All right, now I'm going to come down to this one, the double black diamonds. So again, bars alone, first step, knock off the 7s by subtraction. Notice when this number and this number are the same, you're generally going to get, you're going to get 0 when you do the subtraction. This is generally a sign of there being one solution a lot of the time. Now, to get rid of the 2/3, I either multiply by the reciprocal or divide. So either you could multiply by 3/2 or divide by 2/3. They're equivalent, okay? I'm going to multiply by the reciprocal because those cancel, giving me 1, because the number times its reciprocal is 1. Anything times 0 is 0. So it's equal to 0. Bars are alone. One solution. Okay? $15. Let's try it. Plug it in. 15 minus 15, 0. Absolute value of 0 is 0. 0 times 2/3 is 0. 0 plus 7 is 7. Okay? Last one. Oh boy, this is a fun one. This is with fractions. So I'm going to start by making these the denominators of these the same because I know that I'm going to have to add. So I'm going to make them 35 by multiplying top and bottom by 5. And I'm going to multiply this one by 7. So it's 21/35. Okay. And I'm just going to do that for now. Then you add on both sides. So I've got 4/5 bars, x plus 1/3 is equal to, so you add, so negative 10. I'm going to add 21/35 on both sides because I'm adding 21/35. Okay. And now what I'm going to get is I'm going to get 10. That's going to be 11/35. Okay. Now I'm going to multiply by 5/4 to cancel that out. This will cancel out like so because 5 goes into 35 7 times. That's the only cancellation I can do because these are prime. So that leaves me with x plus 1/3 is equal to 11 across the top, 28 across the bottom. So it's positive. So x plus 1/3 is equal to positive 11/28, or x plus 1/3 is equal to negative 11/28. And this is going to get kind of ugly, unfortunately, because 3 and 28 have really no common factors other than 1. So my options are basically that I'm going to have to multiply 28 by 3. So 20, 40, 60, 8, 16, 24. So it would be 33 84ths. And this is going to be times 28. And then I subtract on both sides. I get x equals 5 84ths. Okay, same thing here. 28 84ths. It's going to be minus 33 84ths. So this is going to become 33 minus 28, 43 53. X equals negative 61 84ths. Okay, here's what I'll tell you. On a test, this is a tough one, right? You're not going to see fractions as difficult. It's good to know how to work with fractions and to recap our really, really important fraction skills, because I'll tell you, too many kids get to college with no idea how to do this. So you should know how to do this. I will tell you, you're not going to probably see this many crazy fractions, but that is more or less what you do. And if we plug it in, we should see it working out. Okay, so go ahead, rewind, remembering this is a start. If you can do this, good. This is gravy. This is all gravy. You can do that. So if you need to, go back, rewind, take a look at this, and then in a second, I'll move on. All right, so we're making good progress. Thanks for your persistence. We're on to solving absolute value inequalities. And in 2019, 2020, because of some personal sickness, I believe it was. I forget. I think that's why I was out that day. I'm pretty sure it wasn't for a conference. I think I was not feeling well that day. We basically stuck to videos on this one, okay? So what do you need to remember with inequalities? Barcelona, okay? Barcelona, same idea. Now, if the absolute value is more than or greater than or equal to a positive, it's an or. When the bars are alone, if it's greater than or equal to or greater than a negative, or rather less than or equal to or less than a positive, let's start with the positives. It is an and. Okay, so this is greater than or equal to, less than or equal to a positive or less than a positive. So bars eats the positive, or the absolute value, inequality eats the positive, goes away from the absolute value. It's an and. If the bars is greater than or equal to a negative, that's all real numbers, also known as R, because every absolute value is distant, so it's positive or zero, so it's more than a negative. And if bars are less than or equal to or less than a negative, no solution, okay? Now remember, or, shading faces away, and shading comes together. Remember, or, opposite, they both start with O, point in opposite directions, and towards each other. All real numbers, you shade everything. No solution, leave it blank. Don't touch it, okay? Because remember, the shading is what's true. So if it's all real numbers, you shade everything. Everything's true. If it's no solution, you shade nothing. Nothing's true, okay? So let's take a look at this one. First, bars are alone already. Less than a positive. I recommend, if you don't know these rules, we try to solve it first. So let's stick to this. It's going to have a solution because this number is positive. There's nothing really to throw us off. So either x minus 6 is less than or equal to 2, or x minus 6 is greater than or equal to negative 2. So I add the 6 on both sides. X is less than or equal to 8. And I add the 6 on both sides. X is greater than or equal to 4. Let's try to graph it. First, I put my dots. Remember the Sophia H rule. Okay, and notice how these numbers, 8 and 4, are both 2 away from 6. All right, greater than 4. Greater than numbers, are they to the right of 4 or the left of 4? They're to the right of 4. Less than 8, they're to the left, okay? Everything you own in a box to the left. Okay, so if it helps you, start by doing a little piece of shading. But if you see the shading is going towards each other, that's going to be an and. Okay, this is an and. How about this one? Same split. X plus 7 more than 5. x plus 7 less than negative 5. Okay, so we subtract 5 on both sides. And by the way, I did that because the bars are alone. More than negative 2, less than negative 12. Notice how this is a plus 7. So notice how 2 and negative 12 are both 5 away from negative 7. This is negative 7 minus 5. This is negative 7 plus 5. Notice that? So let's start with my negative 2. What kind of dots? Open. All right, greater than negative 2. Where are the numbers that are more than negative 2? To the right or to the left? They are to the right. For example, 0 is more than negative 2. They're to the right. How about the ones that are less than negative 12? They're to the left, to the left, to the left. Okay? Notice how this is an OR. Here's a way to know. Choose a test point, negative 8. Let's see if negative 8 works. Negative 8 plus 7 is negative 1. The absolute value of negative 1 is 1. 1 is not more than rather than 5. So negative 8 should not be shaded. When in doubt, choose a test point. Let's say I had done this here. So I have my dots on the 4 and the 8. I didn't know the shading. Pick 0. Okay? 0 minus 6, that's negative 6. Absolute value is 6. 6 is not less than 2. 0 can't be shaded, therefore it can't be an AND. That's another way to know. Okay? Now I'm going to come down here. Okay, notice bars are not alone. Okay, so let's get them alone. X plus 8 is more than 4. Are we in bars alone? Yes, we are. So let's split it. X plus 8 is more than 4. X plus 8 is less than negative 4 because this is a positive number. I subtract 8 on both sides. X is more than negative 4. Subtract 8. X is less than negative 12. Okay. Notice how, again, negative 4 and negative 12 are both 4 away from negative 8. So negative 4, negative 12. Let's do a test point strategy. Negative 8. Negative 8 plus 8 is 0. Absolute value of 0 is 0. 0 minus 2 is negative 2. Is that more than 2? It is not. So that means that negative 8 should not be shaded. Second method of doing it, looking at the inequalities themselves. Negative 12 less than is to the left, to the left. More than is to the right. Okay, how about this one? So I, again, get the bars alone. Now, the minute you get bars alone and see a negative, you need to be suspicious. Okay, so what I'm saying is I'm not saying no solution necessarily, but remember when we got the bars alone with an equation and we were like, uh-oh, something's not right. You should have the same feeling in your stomach. Okay, this is not good. Let's see what happens. You can't split it in this case, but let's talk about it. Well, I know absolute value, whatever comes out here, let's plug in some numbers. 4. 4 minus 3 is 1. Absolute value is 1. 1's not less than negative 1. So 4 doesn't work. 5. 5 minus 3 is 2. Absolute value of 2 is 2. 2 is not less than 1. What about like negative 6? Negative 6 minus 3 is negative 9. Absolute value of negative 9 is 9. Nope. How about 3? 3 minus 3 is 0. Absolute value of 0 is 0. 0 is greater than 1. No. No solution. Okay, when in doubt, plug in numbers. Because remember, when it's either in this case, when you get a negative, it's either going to be everything works or nothing works. If everything works, you're going to plug in numbers, and over again, they're going to work. If nothing works, you're going to plug in numbers over and over, and nothing's going to work. And I could do this in the original, right? 4 minus 3 is 1. Absolute value is 1. 1 plus 3 is not less than 2. So in this case, no solution, you leave it blank. No solution, you shade nothing. Nothing's true. Okay? Finally, I'm going to come down here. So let's take a look. Here, subtract 5 on both sides. Negative 2, x minus 1, less than negative 14. divide by negative 2. Now remember, x minus 1, what do? Flip it, because you're dividing by a negative, 7. Now you solve it. So I'm going to come over here. X minus 1 is greater than 7. X minus 1 is less than negative 7. I add 1. X is more than 8. I add 1. X is less than negative 6. Okay, so I put my dots. And notice, these are both 7 away from 1, right? Less than, more than. So open dot, test point, 0. 0 minus 1, negative 1. Absolute value of negative 1, 1. Okay, 1 times negative 2, negative 2. Negative 2 plus 5, 3, not less than negative 9. Okay, and 0 minus 1, that wouldn't even be more than negative 7, so it wouldn't work in any case. One way to know that 0 is not a solution, therefore you're shading as an OR. Second way, less than 6, to the left. Okay, greater than 8, it's an OR. So here's my strategies. 1, test point. 2, knowing the rules. 3, shading one piece at a time. Okay, there's multiple ways to know how to shade. You got to pick one that works for you. All right, last one on this set, this here. Adding 5 on both sides, negative 2/3, x plus 2 greater than 11, negative 11 plus 5, that's negative 6. Okay, multiply by negative 3/2, because this is a negative, you got to cancel it. So I get x plus 2. What happens here? Flip the sign, because I multiplied by a negative. What's 3/2 of 6? Well, negative 6. So negative 6 times negative 3 is positive 18. Divided by 2 is 9. Now I split. Bars are alone. It's a positive. Solutions. Okay, so x plus 2 is less than 9, or x plus 2 is greater than negative 9. So x is less than 7. Right? That's 9 above 2. Or x is greater than negative 11. That's 9 below negative 2. Okay? So I've got 7. I've got negative 11. Choose a test point. 0. 0 plus 2. 2. Absolute value of 2. 2. 2/3 of 2. Negative 4/3. Negative 4/3 minus 5 is definitely going to be greater than negative 11. Okay? I think that basically goes without saying. Let's say I plug in negative 2. Let's make it easier for myself. Negative 2 plus 2 is 0. Absolute value of 0 is 0. Negative 2/3 times 0 is 0. Is negative 5, which is all that's left, more than negative 11? Definitely is. So that would indicate you're shading as an AND. Second way to know, less than 7. To the left. More than negative 11. To the right. The shadings come towards each other. Another way to know it's between the middle. Third way to know, bars less than a positive means it's going into the middle. It's an AND. Okay, so there's many ways to know how to do the shading. You got to pick one that works for you. Okay, so I encourage you again, if you need to go back and look through any of these, please do so. Otherwise, in a moment, I'm going to move on to the next problem set. All right, thanks for your patience. I'm coming into absolute value word problems. Again, this was a video only. I suggest you check out my video, and I'll try to throw the card up there to help link to it right around now for you, to help you out. Okay, so the first one, and let me just zoom in to get a little clearer picture. 2 different points in a number line are both 3 units away from a coordinate with a negative 4. Which of the equations gives us the coordinates of both points? Here they are. Okay, so let's reason with this. So 3 units away from the point, the coordinate negative 4. What's 3 units away mean? Negative 1 is 3 units away from negative 4. Okay, and negative 7 is 3 units away from 4. So those have to make this true. So let's take a look. Negative 1 plus 4 is 3, absolute value 3. Negative 7 plus 4 is negative 3, absolute value 3. Let's see what would have happened. If I had done this one, negative 7 would not have worked, because this would have been negative 11, absolute value 11. Okay, Negative 1 plus 3 would be 2. That wouldn't work there. And negative 7 wouldn't work there. So it's got to be A. How about this one? In the equation, x minus 4 equals 3. What could x be? Could it be 7? Could it be 1? Could it be 7 or 1? Could it be 7 or negative 1? Let's just do process of elimination. 7 minus 4. Let's plug it in, right? It's 3. Absolute value of 3 is 3. So that could be it. 1 minus 4 is negative 3. Absolute value of negative 3 is 3. So 1 could be it. Okay, that immediately means this is probably it. Let's just check. Negative 1 minus 4 is negative 5. Nope, that's not going to work. It's 7 or 1. Never get suckered in to the draw. It's trying to draw you. It's trying to say, up, 7 works. Hit 7. Don't, when you get it, don't immediately think it. Work through it. When you see 7 or 1 especially, or 7 or negative 1, the implication is multiple solutions could work. So see how I tried the possibilities? It only takes a few seconds. The plugin is relatively straightforward. Give it a chance. Okay? Which of the following expressions is equal to 0 for some value of x? So in other words, which one of these could be equal to 0? So let's set them all equal to 0. Notice here, if you subtract 1 and you get the bars alone, x plus 1 in bars is negative 1. How many solutions does that have? 0. Same thing here. Same thing here. Only A will work. Let's see what it is. It turns out it's 1, right? 1 minus, or 2. It's 2, right? 2 minus 1 is 1. Absolute value of 1 is 1. 1 minus 1 is 0. Or it could be 0. 0 minus 1, or rather negative 1. Negative 1 minus negative 1 is negative 2. Absolute value, no, I was right, it was 0, I'm sorry. Because 0 minus 1 is negative 1. Absolute value of negative 1 is 1. 1 minus 0 is 0. Okay, so you got to reason through it. For what value of n is absolute value of n minus 1 plus 1 equal to 0? What is it asking you to do? To set up an inequality, right? So n minus 1 plus 1 equals 0. Get the bars alone. What do we notice? No solution. Okay? All right. This we did in class 2019-2020, but I'll walk through it. You could think of your body as a finely tuned machine. This is actually true, and some people are saying they did this in bio. In order for your body to run smoothly, certain levels within your body have to be within a very tight interval, or else catastrophic outcomes could occur. For example, the acidity, or pH, of your blood must be within 0.5 of 740. This is true. If it's below the level, if the pH is too low, your blood is acidotic, acidosis, meaning acidity in your blood, very bad for your organs. Okay? If it's more than 7 point whatever, if it's too high, your blood is too basic. It's too much of a base. That is bad. Notice how tight that interval is. This is true of a lot of things, right? If your heart was to shoot up by 100 doesn't even seem like a big number. If your heart rate goes up 100 beats per minute more than it is, very, very bad. Goes up by 200, you're probably not going to be alive because that's very, very bad. It goes down by 100, you're definitely probably not alive, all right? Most likely speaking, or you're in a very bad situation, okay? So the numbers seem small, but in your body, everything has to be a finely tuned machine, okay? When it's not, bad stuff will happen. So we're going to write and solve an absolute value inequality that shows the highest and lowest value that your blood pH needs to be in order for it to be within the acceptable range. Notice, and again, I encourage you to check out my recent video on this. I tell you what I want you to write. So we start, step 1. Go back to look at the situation and ask ourselves, what are the acceptable levels in context? Okay? What's the highest it could be? It's got to be within 0.05 of 740. So it could be a max of 7.45 above. Lowest, 7.35, that's below. So my answer has to be a range or an interval such that 7.35 is the lowest and 7.45 is the highest, okay? So here I go. Let's do this out. So set it up. I need an inequality. Now, I do this because the endpoints are included. It could be 7.35. It could be 7.45. That means I need to do an or equal. Here's my pH. It's got to be within, so the within goes over here, of the desired amount goes there. Okay? If I'm right, I'll get this. Let me show you the wrong one, because I see this happen on the test every year. The numbers get flipped. This is the wrong one, and I'll show you why. Let's try to solve it. Okay, so first you do the split up. Then you add 7.4 on both sides. So x is less than or equal to 7.45. X is greater than or equal to 7.35. That's what you get when you add. So they come together. You get 7.35 is less than or equal to x. Notice it's an and, which is less than or equal to 7.45. That's what we know. Let's look at the other one. When I do the split up, all right, this is what I get. Now I add on both sides. Notice when I add here, I'm going to get greater than negative 7.35. Those of you who know your science knows there's no such thing as a negative pH. That immediately should tell you that you've got these numbers flipped around, okay? So this is the correct inequality. This is the correct. Now, if you get it right, if you knew it already, great. But I'm just trying to show you if you get the numbers flipped, because there's only two numbers that you need to use. If you get them flipped, though, that's what it's going to look like. Okay? Now I'm going to go on to one that might get us a little bit worked up. I'm sorry if it did. Guys, this was bad, right? In one of the most shocking scandals of all time, and probably human history, Tom Brady was accused of participating in a scheme to intentionally deflate footballs in what has become known as the infamous Deflategate scandal. The footballs measured at halftime were supposed to be within 3.5. This is called kilopascals, and just another way of measuring, like instead of PSI, of 89.5 kilopascals. Two footballs were measured. One measured 92. One measured 82. Okay? Write an absolute value to determine, basically, I made a typo here. Basically, what I mean is to determine the range of values that the football pressure is allowed to be. So, this is what we know. So, it's got to be within 3.5 kPa of 89.5 kPa. Within. So, let's start. Step one. What could it be? Within it. So, if I go above it, I'm looking at 93 kPas. That's the highest it could be. If I go down, right? It's 86 is the lowest kPas that it could be. Okay? So we start by saying, what could it be? So my absolute value inequality has to show an x that's greater than this and less than this. So in my mind, I now know what my answer is supposed to be. So here's what you should get. The difference between x and 89.5 is less than or equal to 3.5. The difference between the football and 89.5 is within 3.5. Okay? Now, you don't have to solve it, but if you did solve it, this is what you would get. X is greater than or equal to 86 and less than or equal to 93. Now, which of these actually works? Well, let's see. If I plug in 92, here's what I get. 89.5. Let's see what I get. So this one, and this was 92. So 92 minus 89.5 is 2.5. Absolute value of 2.5 is 2.5. Is 2.5 less than 3.5? Yep. So the 92 is okay, did not break the rules. Okay, 82. 82 minus 89.5 is less than, so if it makes it true, it's good. If it makes it false, it's not. Do the subtraction. I get negative 7.5, right? What's the absolute value of 7.5? It's 7.5, or rather negative 7.5 is 7.5. Is 7.5 less than 3.5? It is not. So the answer is, so the 82 kilopascal football broke the rules. Okay? Great. All right, last one. A local business wants to get a sense of how many people come into their store each day. All right? So what do? Well, they create an absolute value function to model the number of people who enter their store per hour, X hours after the store opens. Suppose the store opens at 8 a.m. Find the time of day when the most customers are entering the store per hour, okay? How many customers per hour are entering the store at that time? Now, think about this. Most. What does that mean? That means I want to know the vertex. Most means highest point. The fact that this is negative means it looks like this. You got to associate negative with facing down. When it's facing down, the top is a maximum. The vertex is a maximum. When it's facing up, the vertex is a minimum, right? We know that from graphical analysis, okay? So what's the vertex? Remember, the vertex makes what happen? It makes the bars equal to 0. So x equals 6 represents the vertex. Now, x means x hours since the store opens. So it's 6 hours since the store opens. So it is 8, 9, 10, 11, 12, 1, 2. So at 2 p.m., x equals 6. The most customers are entering the store per hour. Okay, that represents the vertex. Now, how many are entering the store at that time? Well, what's the vertex? When you plug in 6, this all goes away. So 10 customers are entering per hour. That's actually a pretty small business. It's not a huge business. It's not a lot of customers entering your store per hour. So I don't know how good that is. It must be like the off season. All right. How many customers are entering the store at 7 p.m. and 9 a.m.? So 9 a.m., the store has been open for 1 hour. All right. 7 p.m., the store has been open for, well, it opened at 8, 11 hours. Now, notice, we know this is the x of the vertex. Notice that 6 minus 11 is negative 5. Okay? 1 minus 6, or 6 minus 1, is positive 5. The absolute values of each of those are 5, meaning negative 11 and 1 are the same distance away from the vertex of 6, and so therefore their y values will be the same, right? We know that is true. So let's go ahead and plug in. 11 minus 6 is 5. Absolute value of 5 is 5. 5 times 1.6 is 8.0. So I'll do the 11. I'll show this out. So this is 5. Absolute value of 5 is 5. 5 times 1.6. We know 16, 32, 48, 64, 80, but it's 1.6, not 16, so it's negative 8 plus 10, which is 2. It's the same for both of them. We know that because of the symmetry, but I'll show you just to prove that. So I got 1.6, 1 minus 6 plus 10. Okay, that's negative 1.6 times negative 5 plus 10. But look, these are going to have the same, this absolute value is the same as this absolute value, right? They're both equal to 5. So if these are both 5, these expressions are both the same. We don't have to do any more work. So at 7 p.m. and 9 a.m., 2 customers enter per hour. Extremely dead business. Not a lot going on. I'd be concerned here. Unless they're spending like, this is like a Tesla store and everyone's walking out buying like $100,000 Tesla. Then I'd feel a little bit better. Right. If you have like two people walking out with each with $100,000 Tesla purchase, that's great. Then you're making 200K. But short of that, yikes. All right, so go ahead and make sure you understand that. And if not, I really encourage you to go back and check that again. I'm going to move ahead to the analysis. How do I figure out end behavior? End behavior only occurs, and by the way, this is 2019-2020 2-4. End behavior only occurs when there are arrows on the end. If it starts and if it ends, it's not going off. X is not going to infinity, so there's no real end behavior, more or less. So again, if there's no arrows, the arrows are the key. If there's no arrows, there's not really going to be end behavior. So if the arrows point up this way, pointing up, even if slightly, right? It could be pointing way up, pointing like way, way, way up. Or they could be pointing slightly up, right? It's going to infinity. If they're pointing down, right, a little bit more down, way down, or slightly down, negative infinity. If they're leveling off, they're dead level, it's going to be going to a constant, okay? Two ways to write it. As x goes to infinity, f of x goes to blank. As x goes to negative infinity, f of x goes to blank. It always looks like this every single time. The only thing that changes are the blanks. Remember, the other way you can do it is the limit of f of x as x goes to infinity equals whatever the blank is. The limit of f of x as x goes to negative infinity is blank. This says as x approaches infinity, f of x goes to. As x approaches negative infinity, f of x goes to. So this is like as x goes to negative infinity. So I'll let you write it either way. This, remember, is as x goes to infinity, f of x goes to. These mean the same thing. And this is the same thing as x goes to negative infinity, f of x goes to. Okay? Same thing. You got to choose which way to do it. Let's start with this parabola here. So the domain of the parabola is negative infinity to infinity. Every single x can go in. Remember, this year, that's almost always going to be the case. Next year, we'll start with more limited ranges and domains, rather. The range. What's the lowest value x can be, and what's the highest? Okay. Look at the graph. It doesn't go below 3. Does it hit 3? Yes. So bracket the 3. It's pointing up, meaning we know that the y's go to infinity. Okay? Increasing, decreasing. Where's the y's going up from left to right? They're going up from -1 to infinity, and they're going down from negative infinity to -1. Remember, not 3. Do not use the y value. Use the x. Constant, nowhere. Okay? Or you could write NA. That's fine with me. Y-intercept, 0, 5. X-intercepts, does it touch the x-axis? No. NA. Okay? I could even write, I just want to write, by the way, this is the function for this. This is f of x equals 2 x plus 1 squared plus 3. Notice how similar it is to an absolute value. And you can see it's going up by 2, 6, so there's a similar pattern there. Absolute max, the arrows pointing up show you no abs max. Absolute minimum, boom, it does hit an absolute minimum at -1, 3. Notice that's its vertex. Notice how -1 plays a role in the increasing and decreasing, and the 3 plays a role in the range, okay? End behavior. Okay, so I'm going to do the limit version. So the limit of f of x as x approaches infinity. So as x approaches infinity, f of x approaches is equal to infinity. Okay, the limit of f of x as x goes to negative infinity is, well, as x goes to negative infinity, f of x goes to infinity. So again, that's one way to write it. Other way is as x goes to infinity, f of x goes to infinity. And remember, see the arrows are pointing up. As x goes to negative infinity, f of x goes to infinity. If they're both pointing in the same direction, these should be the same. Okay? So remember, you do either or here. Local max, there's none. There's no place where it goes from increasing to decreasing, but there is a place. So notice how this absolute min also acts as a local min, because going down, 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 and up, 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 up. So if you see a place where it switches over from decreasing to increasing, that -1, that's a sign of a local min. Okay? Line of symmetry, yes, there is one. It's x equals -1. Notice how that's the x of the vertex. Okay? All right. So now I'm going to go on. I am not going to do the additional practice due to timing. I'm going to ask that you seek me out for extra help if that's something you need. Okay? Now I'm going to do a cubic, what's called a cubic graph. We know it's a cubic graph, and you're going to learn next year that the leading coefficient, the number in front of the biggest power of x, is negative because the M behavior is one goes to positive, the other goes to negative. If it's this way and that way, it's going to be a positive leading coefficient. So that's just a little preview. The domain, again, trick question, everything's in the domain. Again, notice there's no holes. By the way, if there's arrows and it's off the graph, we're going to assume there's no problem once we don't see the graph. If there's anything that prevents the domain and the range from being everything, it has to be shown. All right, range. Notice the arrow pointing up, the arrow pointing down. That's negative infinity to infinity, right? There's nothing here to say the range isn't everything. Yes, it's a little restricted here, but the fact that it points up and down means everything is good, right? All of these are being hit, and then all of these are being hit. Increasing. So look, it's increasing from here to here. So I'm going to call this like -1.25. And if it's not clear on a test, I would allow you to use a guesstimate as long as that guesstimate is reasonable. Okay? If you said like 0.75, that would not be reasonable. Here though, if you said 0.5, 0.75, that's a reasonable guesstimate. I will allow that. Decreasing from negative infinity to negative 1.25, and then from 0.75 to infinity, what do we put in the middle? A U to represent the connection. U is the glue, meaning this is a local min, decreasing to increasing. This is a local max. Okay, we'll talk about that in a second. Y-intercept, the origin, 0, 0. X-intercepts, there's two, -2, 0, and 1, 0. I'm still seeing people writing just numbers. They are points. I will take points off if you do not write them as points. Okay, abs max, the fact that it points up to infinity means there is none. There's no one highest point. Absolute min points down, meaning there is no one lowest point. Local max, there is one. So again, here it's kind of tough. We know it's about, again, as long as you use the same x here, you got to keep it consistent. That's fine. I don't know. Maybe you call it 1. Maybe you call it a half. Again, it's got to be a reasonable guesstimate. Local min, again, because I used my -1.25 here, I have to stay consistent, but as long as the guesstimate makes sense, that's fine. And I'll call that 2. Again, as long as they're reasonable numbers in this case, that's fine. Okay, finally, M behavior. I'll show you the 2. As x goes to infinity, and you can do infinity or negative infinity first. It's fine by me, unless I specifically tell you or give you like a stem to fill in. So as x goes to infinity, f of x goes to negative infinity. It's going down, down, down. Now, as x goes to negative infinity, f of x goes to infinity. Beautiful. Okay? second way to do it, the limit as x goes to infinity of f of x. So as x goes to infinity, f of x goes to negative infinity. And the limit as x goes to negative infinity of f of x is infinity. Okay? Remember, if you're having problems writing infinity, here's what you do. You turn the paper on its side, you write an 8, you turn the paper back. Okay? It's like an 8 on its side. All right. Next one, exponential graph. Woo! All right. So remember, this is a trick. Notice it's going flat, flat. This is what we call, remember, this is a horizontal asymptote. It represents a value of y that is, in theory, impossible to achieve. This graph will never have a y of 0. It will get very, very close, right? So this is, I believe, it looks like from a rough guesstimate, approximately f of x equals 3 to the power of x, right? The x is like your exponent. So when you get to the negative powers, you'll get 1/3, 1/9, 1/27, 1/81, 1 2/43, 1 7/29, right? Notice that these are very, very small, 0.33, 0.1111, like really, 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 really small, but they're never equal to 0, okay? And they never will be as long as there's a 1 up top, okay? So let's look at our domain. Again, you can do 3 to the power of anything. If it's negative, it flips it. If it's positive, it makes it really big. If it's 0, anything to the power of 0 is always 1. Range, let's talk about it. So we know it does not go below 0. We can see that. Because of the asymptote, in this case, we put a parenthesis because it never hits 0, okay? That's important. It never hits 0, right? It's a third, a ninth, right? This is -1, -2, -3. These are the x values. -5, -6. It's never going to hit 0. It will get very close, but it never actually obtains the value of 0. Okay, if we look back, this obtains the value of 3. So that's why that one counts, but this one does not. Okay, but where does it shoot to? On the other hand, it shoots to infinity. And exponentials get really, really large in terms of the y's really, really fast. From left to right, where is it increasing? Everywhere. It's increasing everywhere in its domain. Decreasing nowhere. Constant. Again, it looks constant. But what's happening is, believe it or not, if I was to do a Desmos and zoom in, zoom in, zoom in, it wouldn't be constant. It would just be increasing really, really slowly. Okay? Y-intercepts, 0, 1. When you plug in 0, you get 1. X-intercepts, remember, none of them because it looks like it, but it never hits the x-axis. Absolute max, there's none. Absolute min, there is none. The absolute max because of this, and the asymptote means it's always going to keep getting smaller and smaller. End behavior, off to the side. As x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to 0. And this is really beautiful. This captures the true notion of what a limit means. A limit is a number that a function is attempting to obtain, but might not ever actually obtain. It's a number that it gets sufficiently or enough close to, but doesn't ever necessarily hit it. So this function gets sufficiently close to 0. It gets close enough, right? It's like at some point it's like negative, probably like 0.00000000001, but that's still not 0. It's not equal to 0, but it's sufficiently close to 0, okay? Similarly, and that's what a limit when we get to calculus really is. So the limit as x approaches negative infinity of f of x, though it never obtains 0, we can make it arbitrarily close to 0 as x gets sufficiently close to a either large or small number when it's negative infinity, or infinity when it's positive infinity. All right, infinite limits are really, really important. Okay? All right, on the back, a line. Let's talk about the line. Domain, again, everything. Range, pointing to infinity and negative infinity in both directions. So again, that's everything. X-intercept, -1, 0. Y-intercept, +1, 0. Okay, abs min, points down. There's none. Abs max, points up. There's none. End behavior. As x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to negative infinity. Again, they're opposite. So usually they're either going to be the same or opposite, as long as one of them is not going to a constant. Line of symmetry, none. Okay, that's kind of a technicality here. There technically is one. You could say if you go through y equals -x that you could do the fold. You could make that case, right? Because if you flip it over that line, it's technicality. It might be worth talking about, so that's okay. Increasing. Where is it increasing? It's always increasing, right? The slope of a line is the same. The slope is positive. It's always going up. Decreasing. Nowhere. Positive. For what x is y positive? Well, here's where it's 0. So it's positive from -1 to infinity. And it's negative from -infinity to -1. Again, notice how the x-intercept makes its way into the positive and negative. And remember, because of the x-intercept, y is 0, we never put brackets on these, okay? All right, last one. Piecewise. So domain, everything. Range, okay, not everything. It points up, but believe it or not, this is 1, -1. So it obtains a value of -1 to infinity. It actually has a lowest. If there's no arrow pointing down, then that's a sign there's probably a lowest. If there's no arrow pointing up, there's probably a highest. X-intercepts, -3, 0, 1, 0, 3, 0. Okay, there could be more, but because it's a function, there's only ever going to be one y-intercept, because that means if there was more than one, there'd be multiple numbers where if you plugged in 0, you would get that number, and that's not a function. Absolute min, there is one. It's 2, -1. Absolute max, there are none. Now, I want to point out, local min. -3, 0 is a local min. And 2, -1, local min. Local max is -1, 2. Okay, I just wanted to add that because it's a place where it goes up, 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 down, down, down. So anywhere where the increasing flips to decreasing is a local max. Anywhere where the decreasing flips to increasing is a local min. Or rather, the decreasing to increasing, local min. Increasing to decreasing, local max. So local min, local max, local min. Okay? End behavior. As x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x also goes to infinity. Okay? Line of symmetry, none. Increasing. So, remember, the local maxes are the cutoffs. So it's increasing from -3 to -1. And then from 2 to infinity. Union 2 to infinity. Where is it decreasing? From -infinity to -3. Notice again how the local min is the cutoff. And from -1 to +2. So union -1 to +2. Okay? Where is it positive? Again, the x-intercepts are going to act in a sense as the cutoffs there. So I would argue -infinity to -3, you've got to stop at -3 because it hits a 0 there. Okay? Union -3 to 1, because there's another part, union 3 to infinity. You have to cut it off because at these points it's 0. So these points can't be included because they're not positive or negative. And then finally, there is one place where it's negative, and that is from -1 to +3. Now again, notice the x-intercepts make their way in. So -3, 1, and 3. -3, 1, and 3. Okay? So folks, I really appreciate you sitting through this. I know this was a very long video, more than an hour long. Think about the time it took me to put this together. It was not easy on any of our accounts. I appreciate you sticking through this, okay? I hope that everyone's able to use this to be ready for the test. I know we can all do it, but you got to keep staying strong at this, okay? So again, I encourage you to go through this video, take a look through every important part of it, make sure you can master this because we have that test coming up. And remember, you can do it. All right, so keep the questions coming, keep loving math, and you have a wonderful day.